Instance of having to apply De Morgan's law, but applying De Morgan's law to both sides of this or here. Okay, De Morgan's law has to be applied to both sides, so it applies to this side and it applies to this side. You don't do it to the whole thing, so we can leave that in the middle. So let's apply De Morgan's law to this part first, because basically we want to get rid of a bar. It's going across two variables here, the two variables A and B, and there's a bar sitting right on top of them, and we've got a bar sitting right on top of those. So we want to apply it to this part and then to this part. So let's do it to this part. So there's the A and B with a bar at the top of it. So that becomes, okay, remember we swap the variables, we swap the operator, and we remove the bar. Okay, so we're applying De Morgan's law to this, gives to that gives us this one over here. Now let's do the same to this one here. So I've got A and not B with a bar over the top. So if I apply De Morgan's law to that, I'll swap the variables there. So I get A and B. So I started with A and I've got not B. That changes to that, and then I'm left with that. So now let's look at it. So we've got A, or not B, or not A, or B. Okay, so we have the brackets around those things. Now it's all or, so we can actually collapse all that down. Okay, so we can pretty much ignore the brackets now. So we've got A, or not A, or not B or B. So if we've got not A or not A, that's the same as saying not A. And then we've got a B and a not B. So we've got a B here and we've got a not B. So we've got an or on those. So how does that work? So if I've got B here, 0 and 1, there's not B, 1 or 0, and if it's an OR on those, then what do I get? I get 1 and a 1. I always get a 1. Okay, anything or 1 is 1, so the final answer should be 1.